This lecture is on the topic of unit analysis, and it introduces a concept that I call equivalence relations. And it introduces an important method of solving proportionality problems in chemistry. This method is going to be used extensively when we get to do stoichiometry problems. It basically is an extension of the whole idea of the unit conversions that I introduced in the previous lecture. Let me review unit conversions with you. So first of all, unit conversion, to convert something from one set of units to another, we have a conversion equation. So for instance, 60 seconds equals 1 minute. Now, because of this conversion equation, we can come up with something called a conversion factor. And here's an example. 1 minute divided by 60 seconds must equal 1, simply because the two quantities are the same. And we can multiply anything by 1 and we have the same thing. And we use that fact here to convert 120 seconds to minutes. And we write what I have written here and substituting in that conversion factor. And we know that what we're going to get is going to be equal to 120 seconds, simply because the conversion factor equals 1. We get the answer with the units canceling, of course. And we get the answer of 2 minutes. And I emphasize that we choose the conversion factor to make sure that the units cancel appropriately and we convert one set of units into another. Now we want to extend this method to a variety of other kinds of problems that don't necessarily involve unit conversion. And we use this method can be used whenever we have two quantities that are proportional to one another, but not necessarily equal. And ordinarily the two quantities are going to have different units. It works specifically for density problems, and that's the example I want to use to introduce it. So here's the example. The density of copper is 8.96 grams per cubic centimeter. That leads to something that I call an equivalence relation. And that I write it this way. 8.96 grams of copper is equivalent to 1 cubic centimeter of copper. I don't write an equal sign because these two quantities are not equal to one another. They're completely different quantities. They're different units. And for a different, but I also, this is a very important thing that I really want you to do that's going to be important when we do stoichiometry. Notice that I include copper in my label for my units. So this is, and that's appropriate because this is not true for just anything. Other things have different densities, but specifically for copper, if I'm talking about copper, then 8.96 grams of copper is equivalent to 1 cubic centimeter of copper. So here's how, so even though this is not an equality like I do when I do unit conversions, I can still use this to solve something like a density problem. So here's the example. What is the volume of 10 grams of copper? Well, I write my starting, so I understand that I want to end up with a volume of copper, say in cubic centimeters. So I start writing there's my initial amount, 10 grams of copper over 1. And then I use this to define a conversion between grams of copper and cubic centimeters of copper. And why, and how do I know which direction to do it? I do it in such a way that the units cancel appropriately. I get, and then the net is 10 divided by 8.96 with a unit of 1.12 cubic centimeters of copper. I want to illustrate with another example, also with copper density, that shows using this method and also combining with other conversion factors. So here's the problem. What is the mass in pounds of a cube 4 inches on a side, and I neglected to write, of copper? Okay. So the first thing I do is calculate a volume. The volume of a cube is the length of the side to the third power. So I can do 4 inches to the third power, 64 inches cubed. Don't forget that the unit is cubed. So now I write down the equivalence relations I need to solve this problem. The problem asks for a mass in pounds, and so I need this one, the conversion between pounds and grams. 1 pound is 453.6 grams. This comes from the density of copper, and I'm going to be going between cubic inches and cubic centimeters, and so I need the conversion between inches and centimeters. So I start with the volume that I had in the first part. I then convert the cubic inches to cubic centimeters using this conversion factor. Notice that this is written with an equal sign because this is a strict unit conversion. And then in this, the inches cubed is going to cancel the cubic inches here. I still have copper left as a label. Okay, the next thing, this equivalence relation that comes from the density, I use here. And the purpose of that is to get rid of the cubic centimeters and turn it into grams. So cubic centimeters is going to cancel. Cubic centimeters of copper, that cancels. And after this conversion, I will be in the units of grams of copper. And finally, the last one is going to turn the grams into pounds. 453 grams in the denominator and 1 pound in the numerator. And I have this, and what remains for a label is pounds of copper. And if I carry out the calculation with the numbers given, not forgetting to cube the 2.54, I get 20.7 pounds.